Next up from Team Grad students, we've got the guy who's answering some of the big questions. His name is Asparagales Harkessi, but you guys might know him better by his common name, Alex Harkess. And his talk is called Why the Why.
I dedicate this slide to Kelly Daw before I begin. Likely, most people in this room have 23 pairs of chromosomes. One of these pairs is called a sex chromosome. It's what genetically determines you as either a female, having 2 X chromosomes, or a male, having 1 X and 1 Y. Now, under the microscope, the X and the Y chromosome look very different in humans. The Y chromosome being about 10% the size of the X, and having only about 78 genes, relative to the X chromosome's nearly 2,000 genes. So what has been driving the loss of genes on the Y chromosome relative to the human X? Well, we know that this has been happening over the last about 200 million years. What we can't do, though, is go back in time and look at what the Y chromosome used to look like and identify mechanisms that might be initiating this massive loss of genes on the Y chromosome. What we can do, though, is... This is important to us because at the current rate of gene loss on the Y chromosome, we may be facing a possible extinction of the Y chromosome in the next 10 or 20 million years. My research is dedicated to all the men out there. What we can do, though, is look at systems that have very young sex chromosomes, and we can see what does a very young Y chromosome look like and what might be the mechanisms that drive potential degeneration of Y chromosomes relative to the X. I work with asparagus, something that you might find in the vegetable aisle of your grocery store. Asparagus is a very special plant because it's got very young, identical X and Y sex chromosomes. Just like in humans, XX makes a female plant, XY makes a male. Now, when we look at the X and the Y of asparagus under the microscope, very unlike humans, they look identical to each other. But when we look a little bit closer at the DNA level, and we compare the X to the Y, and look along its length for differences that might be specific to the gender, what we see is that the Y chromosome is a little bit different from the X. And that specifically, the Y chromosome has a region bound on the left side and the right side that contains genes that are essential for maleness. Now, in this region, it essentially is acting like a trap. We know that these genes need to be on the Y chromosome, so the Y will do everything to keep them in place. Now, like any good trap, things can come in, but things can't come out. So when we look at the Y chromosome relative to the X, what we find is that on the Y chromosome, these potentially harmful DNA elements called transposons are accumulating in this trap on the Y, and they're not being able to be let out. Now, what this eventually is ending up is that maybe the Y chromosome is going to accumulate as many of these elements as possible, which eventually may be harmful to the Y. So perhaps a more terrible story than anything is that maybe Y chromosomes are born to be destroyed, and that there's no stopping this eventual degeneration of the Y chromosome. Thank you.